Hi students, welcome to lesson 5.3, solving quadratic functions. And as you've probably already noticed, there is a warm-up to start this lesson. And the warm-up asks you to find the x-intercept of the function f of x is equal to negative 3x plus 9. So again, notice it's the x-intercept, not the y-intercept, because you can see very clearly the y-intercept is 9. So we want to know what the x-intercept is. So please pause the video now and find the x-intercept of that function. Okay, so you may recall that the x-intercept occurs when y is equal to 0, and so you could just simply plug 0 in for y and solve this equation to find out what x is, and it turns out that x must be 3. So, and then you can check that by plugging 3 back in to the function, negative 3 times 3, which makes negative 9, plus 9 is 0, and so that works. So that means that the y-intercept is actually the ordered pair 3, 0. So just as the last lesson was split up into 2 days, this lesson will also be split up into 2 days. And the learning goals for today's lesson are first to use a graph and a table to find what are called zeros of a quadratic function. So we're going to be using a graph and table to find the zeros. And secondly, we'll be finding the zeros, again, the zeros, by factoring AC method, square roots, and GCF. So we're going to be utilizing some of those factoring skills that we practiced up so much in the last trimester and really to begin this trimester as well. So let's go ahead and get started on day 1. So in both of those learning goals, I mentioned the term zeros. Well, a zero of a function is a value of the input x that makes the output f of x equal 0, which is really what we were doing there in the warm-up. We were finding the x value that made the output or the y value equal to 0. So this is going to occur when we plug in 0 for y. And the zeros of a function are called the x-intercepts. So we're going to be looking for the x-intercepts of these quadratic functions. So here's a graph of a quadratic function in standard form, ax squared plus bx plus c. And when we talk about what a zero is, what does a zero look like? Well, on a graph, a zero looks like a intersection of the graph with the x-axis. So this is what a zero looks like on the graph. What does a zero look like in the equation? Well, in an equation, a zero is a value for x that you could input into it that would cause the function's value to equal 0. So it's where f of x is equal to 0. So whatever value that we could substitute in for x that would give us an output of 0. Now, if you think about a parabola and its shape, the maximum number of zeros that a parabola could have is 2. Here's 1, there's 2. So that's the most it could actually cross the x-axis. Now if you think about if your parabola, this parabola was, say, moved up so that it was past the x-axis and still facing up, it would not cross at all. So potentially a quadratic function could have no zeros at all. It could possibly have 2, or what about if you had a parabola that was sitting directly on the axis, like maybe if you had one like this that was sitting on the axis, then it could possibly have one solution. So in general, you could have 2, you could have 1, or you could have 0. So let's turn the page. So one way that we could find the zeros of a quadratic function is by actually graphing it. So we talked pretty extensively in the prior 2 lessons about how to graph a function if it's in standard form. So I've got this quadratic equation, f of x is equal to x squared minus 6x plus 8. And I want to go ahead and graph it. And I'm going to see, if at all, where this parabola crosses the x-axis. So I know that this parabola is going to be one that opens upward. And I know that because the a is a positive number. It's actually 1. The B is a -6. The C is 8. These are all going to be important pieces of the puzzle for me to graph this. So the x of symmetry, remember the x of symmetry is found by using the formula that x is equal to the opposite of b over 2a. And so I could find that by taking the opposite of -6. So opposite of -6 divided by 2 times the a, which is 1. So that would give me 6 divided by 2, which is 3. So the x of symmetry is x equals 3. So I could put that on my graph. It's going to be that vertical line that runs right through 3, positive 3. So that's x equals 3. And now if I wanted to find the rest of the vertex, the y-coordinate of the vertex, I'd have to substitute 3 into my function for x. So I'd find f of 3. So that would be 3 squared minus 6 times 3 plus 8. So that means it's 9 minus 18 plus 8, which is -1. So that means the vertex is at 3, -1. So it's on this axis here at 3, -1. So there's my vertex right there, 3, -1. I know that the y-intercept, remember that y-intercept is that c value. So I know that's where the y-intercept is, up here at 3. I know I kind of get a freebie point at the exact same distance on the other side of the axis, so I can see that this is 1, 2, 3 units to the left of the x of symmetry. So if I went 1, 2, 3 units, the exact same spot on the other side, then that's another point. And if I were then to connect these to get my graph, that's what my parabola would look like. So we said that what a zero of a quadratic function is graphically is the place where it crosses the x-axis. Well, you could see that this crosses the x-axis in these 2 points. So if I had to estimate what the zeros were, I would say that it looks like the zeros are at 2 and 4. So I think it looks like the zeros could be represented by the points 2, 0, and 4, 0. So now I'm just estimating it from where the parabola is crossing on the x-axis. Now, a way that I could do that using my graphing calculator is shown here in method 2. What I could do is I could go ahead and enter this equation, that same equation, but as a y equals x squared minus 6x plus 8 into my graphing calculator. I could then hit the second key and the graph, which would then take me over to my table. And then in the table I could actually find the y-intercepts, the x-intercepts, by just looking where the values of y are 0. So you can see there's one of them and there's the other one. So in fact our estimate that we did on our graph were correct. They were at 2, 0 and at 4, 0. Now if you were to hit the graph key on your calculator and looked at this, you would actually see that that point that's directly in the middle between those 2 zeros, right there, that actually is the vertex. And we actually can tell that as well because on our graph up top, we found that 3, -1 was in fact our vertex. See that? There it is. So that vertex is actually positioned directly in the middle of those 2 zeros, or those 2 x-intercepts. So looking at the graph on the calculator, you can also locate those 2 zeros. In fact, one of them is actually already highlighted on the graph here. It's right here, and then the other one right here. And of course, then the vertex is right there. And that's where that vertex is at 3, -1. So to actually have the calculator find the zeros for you, you can follow steps 6 through 11. So once you've put that function into your y equals menu, and you can use that table like I said before and locate the zeros there by just looking for when is the output equal to 0. Then whatever the x coordinate that goes along with it is actually the 0. Okay, so I'm going to include in this video a separate calculator tutorial on how to use your graphing calculator to calculate the zeros of a quadratic function. And so that's actually what I'm going to go to now. So if you have your graphing calculator handy, get it out, and if you don't, you might want to pause and go find it, because the video is going to show you things like how to locate the vertex, how to find the axis of symmetry, and then of course what we're focusing on right now, which is how to find the zeros of the quadratic function. So pause the video now and go get your graphing calculator.
All right, so let's take a look at example B. So example B asks us to find the zeros of g of x is equal to negative x squared minus 2x plus 3 by using a graph and a table with your calculator. So I'm going to go ahead into my calculator and I'm going to type in the equation in my y equals menu. So I'm going to type in negative x squared minus 2x plus 3. So I'm going to hit the graph, just take a look what this looks like, and I can see that parabola. I can see it's a parabola that faces down, which I anticipated because of the negative x squared part. And I want to know what the solutions are. And so you can see I have my table here, and I can actually see, if I go to hit second and table, I can actually see that one of the solutions already is right here. You can see where it's at 1 and 0, so the output is 0. That means the input, that means it's the 0 or the x-intercept. So one of them is at 1, and that you can see that here on the graph as well. You can see where it's touching the x-axis on the right-hand side of that vertical axis is at 1. So if I wanted to know what the other one was, I'd have to work my way backwards on the table. So I'm just going to scroll backwards. And I can see the other one is at negative 3. And that tells me my two solutions are negative 3, 0, and 1, 0. Or in other words, the x value that makes the output 0 is 1, and then also negative 3 is also a solution. And you can see clearly by looking at the graph here that you can see where it actually is crossing at negative 3 and also at 1. So that's how we can use our calculator and using the table. Now we could also go second trace, which gives us the calculator, and we could go down to the second choice, which is 2, and enter, and it will give us the cursor. Then we can have it calculate the zeros just by taking our cursor on one side of the x-axis and pressing enter. That's telling the left-hand bound. So in other words, I'm telling him I want you to look between this left-hand bound and the right-hand bound I'm going to establish for a 0. So I hit enter, and then I scroll back up. Oops, sorry, using the right arrow. I used the wrong one, sorry. And once I get on the other side of that x-axis, so I have my right-hand bound, I'm going to press enter and ask me if I want to guess, and I don't, so I press enter again, and it'll tell me that solution. So the 0 is at negative 3, and the y is 0. And I can do that same thing again, and this time, so I go to second and trace, which is the calculate, go down to 2. I can scroll over and find the left-hand bound. So I want to be on the left-hand side of that solution. So just before I get to it, so when I'm on the left-hand side of that solution, I'm going to press enter. And then I'm going to continue to scroll down and establish a right-hand bound. So I got to go past that x-axis and establish a right-hand bound. Press enter. Ask me if I want to guess. Nope. So I press enter again, and it'll give me the other 0 at 1, 0. So that's two different ways, one using the table and one using the second calculate zeros function.
Okay, so we did example B in the video tutorial for the calculator, and we found that our two solutions were 1, 0 and negative 3, 0. So we could write those as ordered pairs, 1, 0 and negative 3, 0. That's when we're writing them as x-intercepts, or if we're writing as zeros, we would label them as 1 and negative 3. So it just depends on whether you want to write them as like x-intercepts, which would be then it's like an ordered pair, so you have to write them as an ordered pair, or if we're just listing out the zeros, we'd say 1 and negative 3. So you can also find zeros using algebra. For example, to find the zeros of f of x is equal to x squared plus 2x minus 3, you can simply set the function equal to 0. So in other words, we could substitute in 0 for the function, and then we could solve the equation in different ways. We'll look at factoring as a way of solving algebraically. We'll look at the quadratic formula. But we do this, we set this equal to 0 because remember these x-intercepts we're talking about are where the function's output is 0. So setting the function equal to 0 will give us the zeros or x values of the function where they are when it crosses the x-axis, or where the function's value or output is 0. So when we think about solving algebraically and we substitute in 0 for f of x, we actually sometimes will call what we find these zeros, we actually call them the roots of the equation, or we might also call them the solutions. So let's go ahead and turn the page and let's take a look at solving algebraically.
Okay, so you can find the roots of some quadratic functions by factoring and applying the zero product property. So this is kind of a sort of a little semantics thing, but because zeros, x-intercepts, and now what we're going to call solutions or roots, they all really kind of mean the same thing. But when we are talking about quadratic functions, so when they're written in like f of x equals, ax squared plus bx plus c, or maybe vertex form, we actually call the place where the graph crosses the x-axis the zeros or the x-intercepts. But if we have an equation, so now if we put 0 in place of f of x, and we now have created an equation, then we say that those are called solutions or roots. Now the zero product property is that property that says if you multiply two things and you get 0, that means one or the other or both of the numbers must have been 0. So it basically says this, that if a times b is equal to 0, then a equals 0 or b must equal 0. Now how we can use that along with factoring to solve a quadratic equation is by, well, first of all, knowing that when we talk about the solutions or the roots or the zeros or whatever, we mean the value of x, or the input, when the output is 0. So if we were to take an equation like f of x is equal to x squared minus 4x minus 12, and we put in place of the y, or the f of x, 0, and we wanted to find the solutions or the value of x that make this true, we could use factoring. So we could take this quadratic equation here and we could factor it using our AC method, or if we had a special case like a difference of squares or perfect square trinomial or whatever, we could factor this, and then once we had the two binomial factors, so we get these two binomial factors here, and we say that the product of those are equal to 0, well, that means that either one of these or both of these binomials must equal to 0. So let's first of all take a look at factoring x squared minus 4x minus 12. So if we use the AC method, so we say a times c, so our a times c is 1 times negative 12, that's negative 12. So we need to know the factors of negative 12 that add up to negative 4. So that would be negative 6 and positive 2. And this is where we take that middle term then, and we break it up into two separate terms that have a sum of negative 4x by using negative 6x and positive 2x. And either one of those can go first. So I'm going to go ahead and put the minus 6x first, but it doesn't really matter. Plus 2x minus 12, and then we're going to do some factor by grouping by splitting these up 2 and 2. So we take a look at the first two, and the greatest common factor that we can take out of both of those is x, and that leaves me with x minus 6. And then out of the second group we can take out a positive 2, and that leaves us with x minus 6. And that means our final factored form for this quadratic is x plus 2 x minus 6 in either order. And so what this is saying is that the product of these two binomials is 0 using the zero product property. Either x plus 2 must equal 0 or x minus 6 must equal 0. And by solving these little equations, we're going to get the solutions. So to solve the x plus 2 equals 0, I subtract 2, and that's going to tell me that my x must equal negative 2. And again, I just got that by subtracting 2 from both sides. And then with the other one, I'd have to add 6 to both sides. So my other possibility is x could equal 6. And those are my two solutions. If I were to take both of those values and one at a time substitute them back into that original equation, we would see that that would give us an output of 0, which means those are the two solutions. So let's go ahead and take a look at another one. So this time my function is g of x is equal to 3x squared plus 18x. So if I wanted to find the zeros, I substitute in place of the y, or the g of x, I substitute in 0, and then I factor the right-hand side of the equation. Well, if I look at this, you know, I'm kind of guided by the fact that there's just two terms. So when I have just two terms, and it's not like a difference of squares or something like that, most likely all I'm going to really be able to do is find a GCF. So if I were to take out the greatest common factor of 3x squared and 18x, it would be 3x. So I'm going to take out that 3x, and I'm left with x plus 6. And what that means then, using the zero product property, is that either 3x must be equal to 0, or x plus 6 must be equal to 0. And I can solve those two equations, and that'll give me my two solutions, which we said the maximum number of solutions we could have is 2. So to solve the top one, I'd have to divide both sides by 3, and that would give me a value of x of 0. So that means one of the solutions is actually at 0, and the other one I would get by subtracting 6 from both sides, so I'd get x equals negative 6. So my two solutions, my two values, that when I substitute them back into the original, that would give me an output of 0 are 0 itself and negative 6. And you want to feel free to go back and substitute those back in and check them. So we're to a point where I think we've done a couple of them, and you see that what we do is basically factor the quadratic. We substitute in 0 for the function f of x, and we factor and then use the zero product property. So I'd like you to take a moment to try C. You can tune back in and check your work, and then if we do okay, then you may go on and we'll have you do D as well. So go ahead and pause the video now. We're going to make C a you try question. So give it a shot, tune back in to see how you did. Okay, so our solutions should be 6 and negative 1. So the factored form would be x minus 6 and x plus 1, and the value that would make the x minus 6 equal to 0 is positive 6, and the value that would make the x plus 1 equal to 0 is negative 1. So my two solutions are 6 and negative 1, and of course you may plug them back into the original and check, but the output for both of those should be 0. All right, so we're going to try one last one before we end the lesson for today. And so we've got to take our function and factor by using the AC method. So the first thing we do is that we put in 0 for g of x, and then we're going to see what do we have to find factors of to make the middle term. So we do the a and the c. The a times our c would be 2 times negative 18, which equals negative 36. So we're looking for factors of negative 36 that are going to make a positive 9. And so I know that they're going to have different signs because it's negative. So I need one of them to be negative, one to be positive, and they have to make a positive 9. So I started thinking right away about like 12 and 3. And so if I wanted it to be a positive 9 and I made my 12 positive, I could make my 3 negative. And so this could be the pair that we use, would be a positive 12 and a negative 3. Because they add up to make that positive 9. So we go ahead and we split that middle term up, and our quadratic becomes a 4-term polynomial like this. And that way we can split it down the middle, and we can factor by grouping. So what can I factor out of the first group? Well, I could take out an x. It looks like all that I can take out. And that leaves me with 2x minus 3. And out of the second grouping, let's see, I could take a 6 out of both. So take a 6 out of the 12x, it leaves me with 2x. And a 6 out of the negative 18 leaves me with minus 3. And so these are the two binomial factors. Let's see, we'll write those down the side. They are x plus 6 and 2x minus 3. And that has to equal 0. So using the zero product property, the first binomial would be made 0 by a negative 6. And the second one with a positive 3/2. And if you have to, go ahead and set that 2x minus 3 equal to 0 and solve it that way. What you'd have to do is add 3 to both sides and then divide by 2. And so I kind of get into that point where I can just do that in my head. And so the two solutions are negative 6 and then 3/2 or 1.5. So those are my two solutions, and that is it for our lesson today. So I'll see you in class.